Well, welcome everyone. My name is Janis Griffin, and my little talk is going to be on Oracle 23ai's vector search. And a little bit about myself. And let me see if I can change why I'm not being able to change the screen. Okay, there we go. A little bit about myself. I've been a long time DBA. I started out with Oracle version 3 back in the day. At the time, I was going to college, and it was a part-time software librarian in a manufacturing firm. And the VP of data processing at the time brought in Oracle. And they said, okay, who wants to be the DBA? And I raised my hand. So that's how I started out with Oracle. I actually was an Oracle ACE director before COVID. I had to step down because I couldn't keep up with all the stuff you have to do. But I'm really happy to be back as an Oracle ACE Pro. Okay, let's get started. I'm just going to go in and set some, level set key concepts about machine learning, because you can't really talk about vector or vector search without, kind of knowing the whole deal. So machine learning is nothing new. It's been around for a long time. Back in the 80s, I think there was, I don't know. Anyway, I'm not going to go into the history of it, but basically it's not like traditional programming. It basically has the ability to learn by analyzing data patterns. And the main thing that I like is just this one little, graph here kind of says it. You have your data science, you have artificial intelligence, with machine learning makes up a part of that. And within that, there's several, ways machine learning works. And within that, there are these neural networks that are kind of like the human brain that have been created. And Oracle supports this convolutional neural network, if you will. And what that means is it's grid-like images, or like data that, it can quickly, analyze and figure out image recognition and do good classifications. Now, you can't talk about vectors unless you understood vector searches. And vectors really are building blocks representing and manipulating machine learning. But vector search is really a technique of retrieval. Very large data sets. Basically, it stores and groups items based on their vector representation, which is called vector embeddings. Now, vector embeddings basically are strings of numbers or arrays of numbers, really, and they correspond to, an attribute of an item. So, I just thought, well, I don't know why I was thinking I bought a pair of shoes. I think that's why I came up with this example. But, you think about it, any item has a lot of attributes. So you look at shoes, I listed 3 here, but it probably has a lot more attributes. So vector embedding is represented by an array of numbers, and each number is, an attribute. So this is an example of a, very simple vector embedding where you can see the numbers, actually separated by commas. Now, the embeddings can represent a document, an image, audio, and video files, all kinds of information like that. And Raja, showed an excellent example of chunking that data because it can be very large. And vectors themselves can be very large. Any attribute, any item can have hundreds or thousands of dimensions, which equate to millions or billions of vector embeddings. So the data becomes quite large, quite fast. And the process of generating vector is called vectorization. If you ever see similarity search or near neighbor search, it's just basically a vector search. Okay, where they're stored and accessed, well, historically, vectors were stored in, vector databases, any database that supports vectors. Now, lately, a lot of the relational database has been adding, the vector functionality, and the way they're doing it, especially Oracle's the lead in this, I think, is actually, storing vector embeddings as a vector data type. So it's real easy to, actually, just kind of pick up and keep going without having to learn a whole lot of new stuff. Like I said, vectors can be, there could be millions or billions of vectors. So the processing of these can take a lot of CPU. In order to kind of fix that, there are some advanced indexing techniques you have here. And I've listed several here, as you can see. I'm not sure if this is a complete list on all vector databases, but the 2 Oracle supports is inverted file index, which is, abbreviated IVF, or the hierarchical navigable small world, which is HNSW, which it's an in-memory index. The other one can be on disk, just so you know. And each type of index has a different trade-off. And basically, it's speed versus accuracy. So you have to kind of take that into consideration, especially when you're trying to bring back a data set and you need it accurate, or you have to, it doesn't matter. Recently, Oracle just added a new hybrid vector index. And this is pretty interesting to me because it's a combination of Oracle text index and vector index on your unstructured data. So it's going to even be a little more accurate, I think, in doing that. I've tried playing with it, but I don't know that my environment has the up-to-date things. This is just hot off the press, I think, because a lot of the documentation didn't stand up for what I was looking at in my database. So I think I'm probably a version behind. Okay, so another term that you'll hear is large language models, or LLMs. And basically, LLMs are designed to understand and generate human language, and they're trained on large amounts of text data. Millions and billions of parameters are, they learn, from the training data. And there's an underlying transformer, which, here's the neural networks where they play in. And, this is where Raja had a really nice slide that talks about the encoder and decoder and how this works. I've got another slide that I'll go into in more detail, but his example was really good. Transformer LLMs are capable of self-learning. So RAG, as Raja had mentioned, is a retrieval-augmented generation, and it's another technique within ML. And what's nice about retrieval-augmented generations is you can actually give the LLM more information on the fly as it generates the answer. So you get relevant information from your business database. And that's, what really you're doing when you set up these vectors, and vector embeddings. So the way it works, user gives a query, asks a question, and the query encoder basically converts that into a dense vector representation. And then the retrieval process, basically, it searches the internal knowledge database using the query vector. So if you have, set up, Oracle database and given it a table and, embedded vectors, there, basically it'll go look at those. And then it'll come up with similarity scores, and then it'll actually retrieve documents from the original knowledge that it has, and then it generates a response with the decoder, and it uses both the retrieved information from its database, business database, if you will, and its own knowledge. So the benefits of RAG over standard LLM is that it can be more business oriented and it be more up to date and more accurate for your business. So, and you can actually quickly change, the different knowledge sources by adjusting the retrieval process. So it's really easy to, modify, and, it's not a lot of work to do that. Just a little bit of history about Oracle database. It's been a machine learning engine for, since 1999. And I just had to mention this because it kind of at awe at Oracle, because it acquired the machine learning technologies in 1999 from Thinking Machine Corporation. And it actually brought over all its developers. And the rationale behind this was, data is big, and it was growing. And you think back at 1999, it isn't as big as it is now. In fact, I think I have one presentation, I talk about zettabytes of data in our universe. So huge amounts of data. But, algorithms still are really small, or relatively small. So Oracle's thought was, why not move the algorithms to the data as opposed to moving the data to the algorithms? And, it's a smart move, in my opinion, because I think about it today. We have at Quest, we have a really good product called SharePlex. It's, actually selling by hotcakes right now, because a lot of people are taking their business data and shipping it out to data lakes and stuff. And, SharePlex actually does that. But the thing is, they don't have to do that if they, it can use Oracle now, 23AI, which has the vectors embedding in it that, with RAG can actually enhance its own database. So I think it's kind of exciting. Anyway, the history, you can see, when Oracle started using machine learning on itself, on the engine itself, when 12.2 adaptive plans came about, they kind of self-learn and can see 19C automatic indexing, and then there's over 30 free algorithms they give. 23 AI, like I said, basically you can use SQL to build models. You can run machine learning directly on business data. Here's an example of, just creating as a data type. You give it a column name. The data type is vector. And then you can spell out what a vector looks like. So you can give the number of dimensions if you want. You can give it the format of integer, floating, what have you. You can tell it if it's dense, or if you leave that off, it'll be sparse. Or you can just do a star.star, which will basically let Oracle decide. There's no need to move data to another machine learning engine because if you have Oracle 23 AI. And this is kind of what it supports, the LLMs and the RAG. It uses Onyx format support. It has API and SQL support for vectors. And then it extends, applications for both structured and unstructured data types. Oracle AI vector search details, you need to be on Oracle 23.4 or higher. I mean, if you're just looking at this stuff now, you'll be on the right version because I just downloaded, I think in February, this version. And I think I'm already out of date. I don't know, I haven't done it, but just because of the new index, and I'm wondering if I should need to upgrade. But with 23 AI free, you can, use it. Autonomous database, you can use it, or Oracle engineered systems. Similarity searches leverage data semantics, meaning they understand their meaning in context, works on unstructured data. You can actually download from Hugging Face, this all mini LM, that's the one I'm using. There's probably other ones you can use out there, but you can use this new package, DBMS Vector, load Onyx model, and that'll load it up for you. I think I've got examples coming up. So, vector searches uses distance metrics. And what that means, it has to calculate the distance between two vectors. And the closer it is, depending on the calculation, the more similar they are. So there's several metrics, and I'm not sure I have them all listed here, but there's several distance metrics that you can choose from with Oracle. There's cosine similarity metric, which basically is the default. So if you don't mention what distance metric you want, it'll default to cosine. And it focuses, like most of these focuses on the direction and size. Cosine actually focuses on the angle, which is the direction between vectors, and it ignores their magnitude or size. Euclidean, and these are the two I played with. This metric measures a straight line distance between the two, but it also considers magnitude. So this, I played with these two. And, I'm thinking this one, the Euclidean, might be more accurate depending on the information. It's just because it takes into more consideration. Not sure, haven't played with enough, but, and like I said, there's more of them out there that you may want to look at depending on your need. Vector distance is a function that Oracle provides to actually calculate the distance between the two vectors. And then, of course, these are the indexing techniques that you can use. There's trade-offs with the indexes, again, like I said, speed versus accuracy, depending on which ones, and I've got examples of that. Now to load this up, and this is just something, I did it through Autonomous. You can actually go in and create buckets and do this all through the UI and OCI. But what you can do here, and I actually, Sherry LaMonica actually wrote this nice little blog out here, and I kind of took her direction, and this is a script that you can just load it up, and you can go out. You got to first create a credential, like Raja said, and then you actually have to give it the location of the model that you want, and then you just do DBMS Cloud, get object, and then you just load it with the load Onyx model. Now, one thing with 23 AI, the free, which I have, depending on the version, you have to install DBMS Cloud. It doesn't come with it. I hope they change that, but the version I had to walk through and install DBMS Cloud, which was kind of tedious. Okay, so steps to use this mini LM is basically, if you want to, make sure you have it, you can look at user mining models. And you can, it has more fields than that. In fact, you can get the version here if you want to see what version that you've loaded up and all that. example of vector embeddings with the vector embedding function. Here I'm just sending in a 4-word string, and I do select, pass that function vector embedding, give it the model, saying using, my string says how now brown cow as data, and then I give it a column name, and it just spits back the embedded vector column. So as you can see here, it's a string of numbers, separated by commas. And this is quite large. I truncated that. Here is just an example of creating a table with it, and I just created this table with ID info, has kind of a summary, and then I just gave it a V for the vector column, and I used star.star and let Oracle decide, inserted a bunch of data, and then I turned around. I could have, inserted the vector at the same time field, but I, decided to update it just so you could see that again. And there's what I've inserted. So similarity query. This is an example, and I'm kind of I hate to say anal, but I am when it comes to really wanting to see the data. So this is the size of one of those vectors, and basically I decided, well, I want to do a similarity search. So I was stubborn in passing it the actual vector field. And to do this, I had to go out and find what was similar in info. So I went out and I selected an info column where ID equals 909. So my query to actually return similarity columns or similar columns was to not include 909, but oh, by the way, get the vector distance of other vectors, V, and that's like this vector here, 909, and use cosine distance metric, and the fetch then the approximate first 3 rows. So, this is what I did. Very tedious because SQL Plus wouldn't let me enter it all in because it was over 4,999 characters. So I had to put carriage returns, as you see these lines, to get it to work. But anyway, as you can see here, here it came back. I looked for Oracle Cloud Word Milan and gave it this string to give me similar ones, and you can see it returned pretty similar, for the first 3. Now, this is nonsense. You would probably never do that. And because of this error, and it's too tedious, a better way is to create a function and pass, the vector field back to the query you need. So that's what I did. I created a function, passing in the ID and then coming back. So this one, I found something on boats, and so I looked up the ID for that. And then I kind of used SQL Plus, environment variables, or the variables to pass, and so I could just run it again and again. And so this came back with foiling sailboats are fast was what I was searching for, and it came back with sloops have 1 mast, catamarans have 2 hulls, and then it says man overboard, which I had to smile out because it did figure out water and overboard might be boats, but kind of not really. And the thing is about you have to worry about your data set and how good is your data, and also what you're telling the what you're asking for, because if I put more than maybe I said give me the first 10. I don't have any more records for anything about boats in this data set. So it's going to give you hallucinations eventually because it doesn't know any better. It just doesn't have any, can't match anything. So hallucinations are, false data, I guess, when they return. I decided to write this again. There's a live lab on movies, and I kind of, borrowed their data set, if you will. And I just, wanted a little larger data set. So this is movies, and then ran that same query, just passing it different IDs. And I was looking for Handmaid's Tale summary. So this is the field that I vectorized, and it came back with similar summaries, if you will. It's pretty impressive. I kind of had a lot of fun in dealing and looking at this. I can see where it has a lot of opportunities for business applications to get more personal, to actually have the competitive edge in their data. Okay, so like I said, these were small data sets that I used, but even then it was kind of slow to do this. So vector indexes are very important. You can, exact searches are very heavy compute resources, and in fact, you almost need GPUs in order to do some of this, especially on these billion vector columns. So it's better to do approximate indexes. They may be less accurate, but they're less costly. So there's two types of vectors, like I said, IVF, which is a partition-based index, and then there's HNSW, which is an in-memory. It actually has its separate memory space for this index. So the strengths of HNSW is it's a higher search quality, you get better precision, and it scales for larger data sets. A strength is it's pure in-memory index. It's stored entirely in RAM, and it has its own special place. The weakness is it's high memory requirements because of it. So you might require more memory to store a graph structure. But here's just how you would create this. I'm creating an index on my movie, table, and I'm doing it on the vector, and I'm saying in-memory neighbor graph, and that identifies the HNSW thing. You can actually do longhand, and you get more specific about it. I did not play with that. But to see what type of vector index you would do, you look at the index subtype, to tell you whether it's IVF or HNSW. So, looking at the execution plans, in my small set of data, I only had 3,800 records. You can see I'm excluding one because I'm excluding this one 3270. The cost was $15.28. It read full table scans, did a sort on them. It did 8 million consistent gets, which is quite high, I think. With the other index, basically, are using the HNSW index, it started out with one row and built up to three. It's really pretty. The cost is $3. 2,800 consistent gets. So much better in my little small database. And I could tell it, even though it was small on my little VM that I was running it on. IVF indexes, like I said, they're partitioned index. They could go to disk. Their strengths are the low memory requirements. And, also faster index creation. But I don't really care about that as much. I guess with very large data sets, you might. But low memory requirements, that's one of its strengths. The weakness, though, is it's got low search quality. It's not as, it has as much precision, especially if it's a complex query. It's less scalable, but it's useful if you have memory constraints or you can accept the lower search quality. So how you create that is you give it an organization neighbor partitions. Again, you give it the distance metric, and I use cosine, and with the target accuracy of 95%. You can actually, get specific, and I did play with partitions, and partitions do help the performance of it. It takes a little longer to create, but, I did, I think, 10 and 100, and I think that really makes a difference. As you can see here, this one, with leaving it off, it just created one partition. So cost was $677. It did over 1 million consistent gets, compared to the HNSW index, it doesn't compare. Cost of 3 versus 677. Select AI is a new feature that's Apex written that you can actually ask it a question, and you can actually have it generate your SQL, which I think is fun. It's only an autonomous database, and you have to, or at least I had to, I don't know if this has changed recently, but you have to be in a certain region. I think it's probably because of the GPUs that it needs, because the free regions are different. I'm in Phoenix, but if you're in different countries, you have to be in those regions unless they've just recently changed it. Anyway, I kind of struggle with that. That's why I'm pointing it out. But all you have to do is you have to decide, on an LLM you want to use, and then you have to create a profile for it. And these are the complete set, but at the time I created this is the ones that were available. I don't have a subscription, so I just used OCI GenAI, and so I created my profile with a profile name of GenAI, and then I told it, what, I want to give only these tables to the LLM. So you've got to think about this, especially if you're giving an external, subscription-based LLM. it's your data because you're actually letting them have your data. I mean, I'm sure there's security and all around that, but you do have to point out what you want it to see. So, this is just, me using DBMS AI generate, and I, made it so I could prompt for a question, and, I'm passing that profile and I say chat. And so what I did is I just, said, tell me a story about a lion. And it did a nice little story about a lion. And I thought, well, this is cool. I mean, if I had little kids, I could, come up with, I wouldn't have to write books or buy books anymore. I could just go to AI. Anyway, how it works, you have to set up the profile, and then you can do all of these different things. You can chat, you can run a SQL, which is, default, by the way, narrate, or you can just show the SQL. And so I'm going to run through those real quick. This is my first.
Janis, sorry to interrupt. We're 1 minute over, so I'm not sure how
Okay,
many more
I'm just
slides you
going
have.
to. Oh, that's great. I'll just show this, and then I'll go, and then I'll quit.
Okay, sounds
Okay.
good.
Okay, so select AI chat. I just asked who's the president of the United States, and it came back and it says, well, my cutoff date is 2023, so it's Joe Biden. This was February when I asked it. So I go, what is today? It came up with the right date, but then I said, well, what is your most recent knowledge? And it says, well, my cutoff date is December 23. So you probably, I don't know why it's that old in OCI Gen AI, but you got to make sure you've got recent data. But here it's going against my movie data. I asked it questions. I'm using a chat. It comes back. Here's, running SQL, and I ask it another question. If I don't, put run SQL, it defaults to run SQL. And then here's narrate. And other things, you can do the show SQL, which I did, and you can actually have it write your own SQL for you. So in summary, I think it's worth taking a look at. It's great. We don't have to move data to another place, and try it out. And thank you. Sorry, I ran over.
No, you're fine. Thank you so much.